Hi everyone, my name is Dung Tran and this is my presentation for the Euler Berkeley Lab. So let's get started for the introduction. Let's first get to know about the Euler Berkeley theory. So a little history. So we know that the long bone of the vertebrate, they have to support the weight for the animal. So to resist the compression for bending load, they have to be thick. But the thing is, the thicker the bone, the harder for them to run. So therefore, to run fast, they have to be slender bone. The bone has to be thin, slender. Uh, at the same time, to make the bone light and strong, they have to be hollow also. So in a sense, they break easy. So the Euler buckling in general is a mechanical law. They describe how a bone is can easy to break, how thin the bone can break, and how safely they use to support the animal weight. So in some sense, the Euler buckling is a mode to load the compression there beyond their capacity to see how much they can bend before they break. So for the lab, the material used for this lab is only 10 straw, kitchen scale. This is one of the example I want to show you guys. Uh, Two foam pieces. Here's another one. We need a ruler and a scissor. For the method, so pretty simple. First, you have to gather all the supply, like I mentioned in the previous slide. Uh, then you have to zero your kitchen scale. Next, you have to measure the straw diameter, the length. Oh, sorry. In the unit, it has to be in milliliter. Next, you plot all the data on the Excel sheet, and you place the foam on top of the straw. Next, you apply the force to see how much you can bend. And uh, one thing to mention is you have to record the first moment you notice the straw bend, otherwise you mess up the data. Then same thing, you apply more forces to see when it's break and record the data also when it's break by the unit is to be gram. Then you measure the length and diameter value to help determine their threshold value. Then you just compare the data with your teammate. So for this picture, it's pretty much straightforward, like I mentioned. The blue picture right here is going to represent a straw, and the black picture right here is your foam. So the idea is to try to apply some foam to see when the straw break or bend. For my result, as you can see, this is my first data, my own data, and this is my teammate data. Her name is Sarah. Uh, the first picture right here is for both of us data, but the first one is our load of failure, and this one is our bending load. So from what I noticed is for my data around my length and diameter value of 40 milliliter or 70 milliliter at length, my bone is impossible to break. Any length higher than 70 milliliter, they break easily, and vice versa. Below it, 70 milliliter is impossible to break. So from Sarah data, I noticed her straw diameter is much larger than I am. She have 7 milliliter compared to mine is 5 milliliter. Also, but at the same time, we both noticed as for her data, any data below 70 milliliter, like I mentioned, is impossible to break. As a result, we have the same data. We can confirm that any straw that length shorter than 70 milliliter is impossible to break. As this is the two graph we managed to graph, so we our data very correlation together. Next, let's discussion about how you determine the threshold value. It's pretty much simple, really. All you need to do is just find the data when the straw begin to bend, but they do not break. So in my in my case, my threshold is 40 milliliter or 70 milliliter in length. Um, from the data I mentioned, the longer the bone, the more easy to break. At the same time, the shorter the bone, the more harder it's gonna break. Any length above 70 milliliter, they break easily. Any length below 70 milliliter is impossible to break, according to my data. Also, I noticed all straw is behave differently. So they depend on our length, the material, the thickness, and the force being applied to the straw. The bone will have a larger LD value ratio. So compared to the straw, it's much different. The thickness and their content inside, they have osteoblast, which have the bone is more thicker compared to straw because the bone side they have is more stronger, so impossible to break. Straw is more thinner and more hollow, so they break easily. So compare the bone and the straw is a huge difference. They're not the same. And that's it for my lab for today. And have a nice day. Thank you.